Most welding projects don't fail because of a single mistake. They fail because of a chain of small decisions that compound over time. By the time the weld cracks, the project was already lost long before the arc was struck. One of the earliest causes of failure is poor planning. This shows up as missing measurements, unclear dimensions, or a lack of drawings altogether. When a project starts without a clear plan, every step that follows becomes reactive instead of intentional. Materials get cut based on assumptions. Fit-up becomes forced. Adjustments are made on the fly, and tolerances slowly disappear. Another major issue is the absence of sequencing. Many projects fail because the order of operations was never properly thought through. Parts that should have been welded last are welded first. Components that need axes later are blocked by earlier welds. Heat is introduced too early, causing distortion that could have been avoided if the sequence had been planned correctly. Material selection is another common failure point. Using the wrong grade of steel, incorrect thickness, or incompatible materials can undermine a project before welding even begins. Some materials require preheat, others require controlled cooling. Some combinations introduce galvanic corrosion or cracking risks that aren't obvious until it's too late. Assuming material is straight. Assuming surfaces are square. Assuming factory tolerances are perfect. Steel rarely behaves the way people expect it to. Minor variations multiply when components are assembled, and those variations often get locked in once welding begins. Fit-up is another critical area where projects often fail. Poor joint preparation, uneven gaps, contaminated surfaces, and misalignment all place unnecessary stress on the weld. A welder can only work with what they're given. A perfect weld placed over a poor fit-up is still a compromised joint. Clamping and fixturing are frequently underestimated. Inadequate restraint allows parts to move during welding. Over-clamping can introduce stress that releases later. Without proper fixturing, heat input causes distortion that pulls assemblies out of tolerance, sometimes permanently. Heat management itself is a major contributor to failure. Excessive heat input weakens base material, increases distortion, and alters mechanical properties. Insufficient heat input leads to lack of fusion and weak joints. Welding parameters must match material thickness, joint type, and position, not convenience. Welding sequence within the joint also matters. Long continuous welds without breaks concentrate heat and amplify distortion. Alternating sides, staggering welds, and controlling bead length are all techniques used to manage stress, yet they are often ignored in rush jobs. Joint design plays a major role in success or failure. Undersized welds may not carry the required load. Oversized welds introduce unnecessary heat and stress. Incorrect joint geometry can create stress risers that lead to cracking under load or vibration. Welder technique is another layer in the system. Incorrect travel speed, poor torch or electrode angle, inconsistent arc length, and improper manipulation all affect weld quality. Even skilled welders will struggle if conditions are poor or preparation is inadequate. Consumables are often overlooked. Incorrect filler material, contaminated electrodes, damp rods, or incompatible wire types can introduce defects that aren't visible until failure occurs. Shielding gas selection and flow rate also matter. Too little coverage allows contamination. Too much flow can cause turbulence and draw in air. Environmental conditions contribute as well. Drafts, wind, moisture, temperature extremes, and surface contamination all affect weld quality. Welding outdoors without proper shielding or in cold conditions without preheat increases the risk of defects significantly. Inspection and quality control are another failure point. Projects often skip intermediate checks. Errors that could have been corrected early become locked in as the project progresses. Measuring after welding instead of before is a common and costly mistake. Design loads are frequently misunderstood or underestimated. A weld that looks strong may not be designed to handle cyclic loading, vibration, impact, or fatigue. Without understanding how forces travel through a structure, welds may be placed in positions that experience stress they were never designed to handle. Communication breakdowns also cause failures. Misunderstandings between designers, fabricators, and welders led to incorrect execution. Changes made verbally without documentation create confusion. Assumptions replace clarity. Time pressure and pricing pressure amplify every problem. When a job is underquoted or behind schedule, decisions shift from what is correct to what is fast. Corners get cut. Steps get skipped. Quality becomes optional instead of required. Rework is often mistaken for problem solving. Grinding out welds, forcing parts into place. And patching errors instead of addressing root causes weakens the entire system. Each correction introduces new stress and reduces overall integrity. Post-weld treatment is another neglected area. Some materials require controlled cooling, others benefit from stress relief or post-weld heat treatment. Skipping these steps may not cause immediate failure, but it shortens the life of the structure. Corrosion protection is frequently an afterthought. Poor surface preparation before coating, improper material pairing, or incomplete coverage allows corrosion to start at welds and joints, exactly where structures are most vulnerable. Documentation and repeatability are often missing. When a process isn't documented, mistakes get repeated. Successful outcomes become accidental instead of intentional. There is no baseline for improvement. At the core of all of this is one reality. Welding is not just an act. It is part of a system. When that system is weak, even good welds fail. When the system is strong, welding becomes predictable, repeatable, and reliable. Most project failures are not caused by one dramatic mistake. They are caused by small oversights that compound. Planning issues led to fit-out problems. Fit-out problems force welding compromises. Welding compromises create stress. Stress eventually becomes failure. The difference between projects that last and projects that fail is not luck. It is preparation, understanding, and respect for the entire process from design to final weld. Fix the system first. The welds will follow.